Hello and welcome to my channel. In this video we are going to solve an example from complex numbers which had appeared in JEE Main January 2019 paper 2. Let z be a complex number such that absolute value of z plus z is equal to 3 plus I, where I is equal to square root of -1. Then absolute value of z is equal to. So here in the question it is mentioned that z is a complex number and here we have to find the value of absolute z. So let us represent z as a complex number first. So z is a combination of real number represented as x and an imaginary number that is iy. Now absolute value of z is represented by a formula square root of x square plus y square. That is real number squared plus imaginary number squared. Now once we have got this, let us replace this absolute z and z by their respective representations. So we have here square root of x square plus y square plus x plus iy is equal to 3 plus I. Now the next step is comparing the real numbers from both the sides and the imaginary numbers as well. So on the left hand side the real numbers are square root of x square plus y square plus x because these terms are without the I. And on the right hand side we have a real number 3. Similarly we are going to compare the imaginary terms as well. On the left hand side we have iy and on the right hand side we have plus I. So let us compare them and write here. So comparing the real and imaginary terms on both sides we get square root of x square plus y square plus x equal to 3 and iy is equal to I. Now here on the imaginary side I from the left hand side can divide I from the right hand side. So we have here y is equal to 1. Now since we got the value of y as 1 from the imaginary terms, we can replace the y square by 1 and write here square root of x square plus 1 square. 1 square gives us 1. Now taking plus on the other side of equal to sign, we get 3 minus x. Now let us square both the sides of the equal to sign. So we have here square root of x square plus 1 the whole square is equal to 3 minus x the whole square. Now square of the square root disappears. So on the left hand side we have x square plus 1 is equal to. Now the right hand side follows the algebraic identity a minus b the whole square is equal to a square minus 2ab plus b square. So here a represents 3 and b represents x. So expanding it using this formula we get 3 square minus 2 times 3 times x plus x square. Now x square from the left hand side and x square from the right hand side cancels out each other. So on the left hand side we have 1 and on the right hand side we have 3 square which is 9 minus 2 times 3 is 6 times x. Now let us exchange the places of 6x and 1. So minus 6x becomes plus 6x and 1 becomes minus 1. So 6x will be equal to 9 minus 1 which is 8 or x is equal to 8 over 6 which can be simplified as 4 over 3. Now here we have got the value of y as 1 and x as 4 over 3. Now once we have got this, we have to find out the value of absolute z as it is mentioned in the question. And absolute value of z is given by the formula x square plus y square. So here we have written absolute of z is equal to square root of x square plus y square. Now replacing the value of x and y as 4 over 3 the whole square plus 1 square. So 4 square becomes 16 and 3 square becomes 9 plus 1 square is 1. Now taking a common denominator that is common LCM. Here we are going to multiply the numerator with 9 and denominator as well with 9. So here we have in the numerator 16 plus 9 and a common denominator as 9. Now 16 plus 9 gives us 25. So square root of 25 over 9. This simplifies as square root of 25 is 5 and square root of 9 is 3. So here the absolute value of z is going to be 5 over 3. So let us see if it is in the options above. So here the option is B, 5 over 3. I hope you have understood all the steps and liked the video. If you found this video useful, then you can click on this playlist where you can find more competitive examination questions. And if you are liking my videos, like, share and subscribe to my channel. And thank you for watching.